Okay, I'm back from a break. Where were we? We need, okay, so we have our sound file player, and this sound file player will need to reference a sound file. All right, so let's make our sound files as, I'll call them global variables. And make them here. So sound file. Let's call this the sound. Okay. So this is a pointer. Let's get. I will make a new sound file. All right. I do not have a sound prepared. My mistake. Let's call it sound 1. All right. So let's go through my file system here, and I bet I have some sounds laying around. Here are some sounds. Alright, I'm going to copy this sound file, go to my project. Yeah, you can use with this library you have to use a WAV or an AIF format. No compressed formats will be accepted, and eventually I plan on adding the ability to do that, but it's not a huge priority for me to make the availability of crappy audio files accessible. So it's on the to-do list, but not high on the to-do list. Send me a request in the comments if you really want an MP3 to be in your project. All right, so whoops, sorry. We go to our apps where we generated our app, my apps. Go to the file we're working on, go to the bin, and we'll put the sound in the data folder. So it will automatically look here for the sound. I'm going to change the name of the sound to sound 1. .aif. So this knows, I believe, to look in the data path. Let me verify that. It actually might not. Go to definition. Okay, nope, it does not know to go to the data path, which is fine. So we'll have to use the handy function here of to data path. Saves us the trouble of figuring out what that path would be. All right, so wrapping our sound here. So whatever we put in here, it's going to search the data path for this, and it should find it. That's actually one feature I'm fairly happy with, is that you can draw the sound file, so we can verify that it loaded by drawing it. Sound draw. Let's do 0, 20, 20. I'll make it 400 by 120. Sure. So we won't have to go through the trouble of playing it to verify that it loaded. Okay, great. As you can see, oh, whoa, not great. Huh, that was pretty neat. It printed some stuff. Obviously, I have a cout issue. Okay, I'm going to go ahead and try that. Right. Okay. So it wasn't a sound file issue. I had forgotten that we've added some code here, and it doesn't have, I say get alive, but in our setup function, we never said whether it was alive or dead. So if you have a variable that you're asking for and it's not been instantiated, it has no idea what it's looking for. So let's just go ahead and fix that. When a grain starts, it is of course not currently playing, it'll wait for an impulse. So when the grain starts, oh no, actually we should put this in the constructor. My mistake. No, there's actually two issues now that I'm thinking about it. So we go to our constructor. When we actually create RAM for these grains, they will need to all start dead, which is fairly morbid, I suppose. Alive equals false. However, that's not what actually caused the access violation. What really caused it is we've made... sorry, here we go. We have this array of grains, but we've never actually instantiated these. So in our setup function, we need a for loop to do this, or should use a for loop. For and I equals 0, I is less than max grains, increment I. Grains at I equals new grain. And then that'll do it. Alright, so we should have the same thing without the crashing. So you'll note it worked for a moment, but the first impulse that was registered, it failed. Great. And this sound file looks, you know, boring. There's not a lot of dynamic action here. And I'm wondering if it's I think it is normalized. I think there's an issue with the display. Okay, so we have successfully loaded a sound, and we have a method of starting this. So what we need to do is when we make those grains, we need to give it the memory location of our sound file. So we have our sound file. Right now it's called sound. We'll have multiple sound files later, but for now, just for simplicity, we'll just do the one. So if I do, I might have a function to get that. Let's find out. Jump to definition. Uh-oh. Okay. Okay. Cool. I thought ahead here. In the library, if you want to get the access of the sound file, just the sound file itself, note that there's more to that class than just the data of the sound file. You just write get buffer. Alright, so if we go back to our vap.cpp, we could pass this along in our constructor, which I think is what we should do. So in our constructor, we can say sound get buffer. And this will not return the entire audio file. This will just return the memory location of our buffer. You know what? Let's go back. I think there might be an issue. Sound file player is going to actually need a pointer to the entire sound file class. And the reason for this is the data is not enough. We'll also need to know how big that sound file is for the sound file player. The sound file player will need to know when to loop back to the beginning. So we don't need to access the data. We just need to access the sound file. So we can just give it a sound, which is a pointer. All right, so it won't like that because our constructor has no input methods. All right, oh man, what's the word? I'm just gonna skip over that for now. It's late for me. All right, so grain, this will need a sound file pointer sound. That should be happy since we've included ATK. All right, so we'll need a reference to a sound file here. So this won't actually store the sound file, it will store the memory address of the sound file. So All right, so, and then in this constructor, call it input sound just to make it clear. All right, sound equals input sound. All right. Let's see if this, I'm feeling a little pessimistic here. Okay, so, you know, it didn't fail. I'm still a little skeptical. All right, so this is a very confusing way to use the sound file player in the sound file. I think, yeah, I did include a sound file player example in the ofxATK library. So it might be useful to take a look at that. It's a little more clear how that works. I'm passing references around different files and different classes, so it kind of confuses the situation here, but that might help. All right, so, and I also likely do a video on sound file players. All right, so we have the sound. So when we instantiate the sound file player, the sound player here, we need to tell it which sound it's playing. And to do that, sound player equals new sound. Oh, this should not be in start. This should be in the constructor. Because start will be called multiple times. The constructor will be called at the beginning of the program. Sound player equals new sound player. And our reference will be the sound. All right, so this will be called when we start the program. Let's see if it doesn't complain. I don't hear complaints. Man, I really want to get, I'm going to get rid of that. It's going to bother me to no end. Let's see, if I go to, maybe I'll delete this out of the tutorial, but sound player, where is that? Looking for cout. Oh, no, not in the Mac. Man, cout. Nothing here. It must be in the sound file class. Oh yeah, I remember now. It's in that draw function. Here it is. All right. That was my debugging for the library. I forgot to comment that out. And here's another. Okay, so now when we start the program, we will not get this nonsense. Confirmed. Okay. All right, progress. Okay, so let's look at the grain. We need a way to test this. So the position equals 0. So let's go ahead and start our grain process function. All right, so when we process our position, we'll have to increment. Let's see. We needed to decide on a duration. So there's a couple of technicalities that are a little nuanced and a little, I mean, they don't matter. Granular synthesis, the grains are below 100 milliseconds. It is not my personal opinion that if it exceeds 100 milliseconds, it's no longer a grain. And there's no reason to limit ourselves to 100 milliseconds, is what I'm getting at. You can do a lot more interesting psychoacoustic effects with really short grains. But anyway, so let's make our duration random between, let's say, 5 milliseconds and let's do 200 milliseconds of random. Oh, jeez. Yeah, thanks for the autocorrect, Mac. Okay, great. So our duration is that long. So we'll have to use a phaser, I think. There's, You know what would be really useful, and I'm just finding this out now, would be a one-shot phaser. A phaser is an oscillator that goes from 0 to 1 over a period of time, and it does it periodically. It does it over and over and over again. We could really use a phaser that goes from 0 to 1 and then stops. But at any rate, let's make a phaser. Let's see, what did I call the phaser? It's not a wavetable phaser. I think this is a trivial phaser. So trivial phaser. Phaser. And we're going to have to actually see if I called this the correct one. Must have. All right, so one thing that's going to be a little painful is we'll have to decide the frequency of that phaser. So this phaser understands frequency, but we need to tell the period to be a certain length. So we'll have to do a conversion from the size of the period, which is our duration, to frequency. And you all get to watch me think of how that math works in real time. All right, so process. So we'll, first let's, we have our phaser, let's make it instantiated. So our phaser equals new. And we'll just set the frequency to 1 to begin with, but we'll have to set that each new grain. All right, so let's make a float temp freq each time we start the grain. And this will be, why am I making this harder than it is? The period, this is a day one computer music kind of equation. I'm making it way too hard. I think it's 1,000 divided by the frequency, or the. This may or may not make it to the editing session, but so say our duration's 1,000. We need this to be 1 hertz. If it's the duration's 500, it needs to happen 2 times a second, so 2 hertz. Oh yeah, I was right the first time. I don't know. Sorry I made that so difficult. I'll probably fast forward through some of my thinking there, so I'm not as embarrassed, but you saw me fail hard. It's just 1,000 divided by our frequency, or divided by our duration. That will be our frequency. All right, so if it's if it's 1,000 divided by, if our duration is 1,000 milliseconds, which is a second, it will be 1 hertz, 1 period per second. If it's 1,000 divided by 500 milliseconds, it will be 2 hertz, or 2 times a second. So great. So our phaser will set the frequency to temp freq. All right. So here's another issue, and the reason I kind of wanted it to be one shot. We do have to change the frequency, of course. We also need to make sure the phase begins at 0. It begins at the very beginning of the period. So let's see if I have a set phase option. Yes, great, fantastic. All right. I was probably too excited about that. Okay, so now we have the phaser starting at 0 and it's set to the right period length, or the right frequency. All right. So let's see. And the reason we want that, we'll do phaser. Let's actually just not use any windowing at the moment, and just play the sound file. So sound, I'm switching gears here pretty quickly, so sorry. Sound player, process. Current sample equals our sound player get sample times amplitude. Alright, so each time it's processed, it's maple. Current sample. Did I have a getter for the current sample? Yes. Alright, so when we get the sample, we should just get a scaled version of the audio file playing. However, we haven't started the audio file. So, let's see, we should set the position each time here. We'll get to that later. Oh, we'll get to that now. Oh, there's two. I said position. I need to remember to say index. The words are kind of interchangeable, but we'll need those words differently in this context. So the index is where we are in the sound file. So I hope that I made the sound player set location. Oops. And we'll set the location to of random 0 to 1. Alright, so if I'm not mistaken, I'll go back and check in a second. No matter what sound you have, you set the location from 0 to 1. This is so you don't have to calculate how many samples are in that sound file on your own in your program, or how, yeah, well that's the exact reason. And also you can use a phaser to play it if you wanted to. However, if you do want to set it so many X milliseconds in, which I'm not interested in this particular purpose, you have to do that calculation. Alright, so this will pick a random index, and just to be safe, let's, well, not safe, we need to do this. Sound player, set loop mode to 1, which is standard looping. 0 is off. 1 is standard looping. 2 is ping pong, or like boomerang looping, where it goes forwards, then backwards, then forwards, and backwards. And 4 or 3 is going to be at some point an auto duck looping, but don't have that at the moment. But right. Actually, you know what? Let's not loop this, as I don't want to have to put or loopable audio files as my input. So these files will end naturally. So if it happens to start the grain near the end, it'll just die out earlier than it should have, which is fine with me. Okay, and this would probably have been the standard mode anyway. But okay, so now when we process it and get the sample in our audio thread, we should actually hear sound. They won't be grains. It'll just be playing those audio files. And they won't end, so we'll have that audio file playing eventually 128 in discrete times, which is obnoxious, but we'll close it well before that. Let's actually set the frequency lower. And you know what? Let's also factor in the speed. That way we can tell if different sound files are playing. Sound player, set speed to speed. And our main function here, our audio out function, when they become active, we'll have to say grains at I start. That should start the grain. All right, so this is our function. Time to start using some comments here. Trigger a new grain via the impulse generator. That's all contained. Well, I can keep that. Okay, it's all contained there. So we need a way to accumulate the audio from all of these grains. So we need a for loop, int max grains. So for every single grain, current sample plus equals grains add I get sample. So this will put all of those grains together into one sample. And we'll need to put this at the beginning. Note that I set this equal to 0 here. That was because I knew we'd have to do a plus equal here. You can't do a plus equal if this doesn't already have a value. That might be different from some compilers might give you a break there. I have noticed that in some cases, if you don't instantiate, it just sets it equal to 0. I haven't done any research on that or found out like what works and what doesn't work. But it's best to mind your manners when you're going to an old compiler or a different compiler, that it will work either way. So we're setting it equal to here. That way we can use plus equals here, equal to 0 here. Okay, so this should work. I'm going to go ahead and just turn this down at the end. I'm a little worried. Let's run this. Okay, nothing's working. I did get a massive DC offset sound at the beginning. Ow, and at the end. Interesting. Okay, so I didn't get any errors, which I actually would have preferred an error at this point. So when we process the grain, we're processing the sound file, the amplitude scaled into a reasonable range. Oh, I never did check this. So let's go ahead and go to sound player. It should work either way, but set location. Oh, that's not what I wanted. Why is it like this? If anybody sees the mistake I'm making, I can never seem to decipher how to navigate this environment. Yeah, it's really bizarre. Alright, finally. Alright, so set location 0 to 1. Good. Comments are nice. So that's correct. It should start anywhere in the sound file. Oh, okay. Very, very obvious one, I think. Or at least one issue is obvious. Let's just sound player play, I think. Yeah, play. Oh, and I can. There's an override. I can set the speed in this function. So speed, and we don't need this anymore. And then we'll set the location. So the problem was, at least one problem, was that we never actually told the sound player to play the sound. What is... Okay, I found the issue. You know, I should know my own library a little bit better. I set the loop mode. I don't need to set the loop mode. I need to disable looping. So loop enabled. set loop enabled. There we go. And let's just jump on over to that. Wait, did I just do the same thing? I don't think I have a way to set that in the library. So that is noted. I don't. So in the constructor of the sound file player, I have a few things here, but I don't have a way to. I'm just going to do this for now. Looping enabled is false. I will update the library, so you can do what I'm just doing here. Go to the sound player document and change it. By the time you're watching this, the code here will be updated on GitHub. So if you have a new version of the library, you should be able to do set loop enabled to false, and that will do it. But that won't work now. Matter of fact, okay, I'm retracting. I'm just going to add that now, and so this code can be the same. So sound player set loop enabled false. All right, and then we can just do void set loop enabled boolean new loop enabled equals false. Yeah, I don't know why I just didn't do that. Okay, make sure that's the name of our. Oh, that's. Wow, I'm not in the right file. Sound player. Why is it like this? All right, so I've had this problem all the time with Xcode. Am I doing something? I mean, if you're watching this and you know the mistake I'm making, sometimes if I jump to the definition, it takes me to the actual library. Sometimes it takes me to my header, and it's really frustrating because I can't find a pattern to that. So if you're reading or watching this, just let me know, because it'd be really nice to be able to go to that right now. There we go. See, I don't understand. I did it 3 times in a row, and it behaved differently each of those 3 times. One thing I'll do is get rid of the C out. Actually, I'll comment it out. All right, so what this makes sure is that the sample rate, if it's not matched, it'll adjust the speed accordingly of the actual sound file. All right, so we need to add this code, void set loop enabled, and then it'll still change the what? And I did it again. I did the exact same thing. Sorry for all of you watching that. I just made the same mistake. I guess I'll just keep doing it until it works. Okay, we're here. This is the sound file player class. All right. Now we can do that. We can change the loop enabled to be false. Yeah, if you're using my library and you see issues like that, like I should have just had that function. I just, I'm one person. It's hard to troubleshoot all aspects of the library. It's nearly impossible to troubleshoot everything. So if you find something you like, find something you think is there that's not, let me know. I'll change it as soon as possible. Okay, so everything should be happy in our grain file now. Set loop enabled to false. That is now something we can do, and see how this works. I hear nothing. Let's get rid of this. Try again. Wait, okay, I know the issue. Okay, so everything's great. We're getting the sample. That doesn't matter. We're not actually running the process part of this. So we need to do grains at I process. Now I have around 80% confidence that this will be loud and obnoxious and work. Cool. All right, so that is a little informative. We didn't hear multiple grains at the same time, and the reason that is I never actually marked the grain as alive. So it sees it's false and overwrites the same parameters, picks new random parameters when it comes through. So when we have the start function, we need to mark it as alive. Let's do the very first thing. So alive equals true. Now we should start to get some polyphony. Okay, so I'm not positive that this sound is reaching out. I'm going to pause here for a moment, check the video, and make sure that the sound is getting to the video.